Hey everybody, I'm recording this little intro for this video after I've already recorded the remainder of the video, and the reason why is because I need to make a disclaimer for the manual reviewer of this video from YouTube. This video does not at all go against the community guidelines or the terms of service for YouTube. It does not violate the firearms policy because it does not show any fabrication, any manufacturing or modification of firearms parts. I will be demonstrating parts, and I will be demonstrating parts that are modified, pre-modified parts, but I will not at all show the process of how this is done. This is in light to the last video that I posted about introducing an oversized cam to the system, and YouTube decided that me showing what happens whenever you introduce an oversized cam is somehow going against it goes against the terms of service for firearms. So that's obviously not correct, because I don't show any modification in that video. I simply show parts and what happens whenever they come together. But no actual modification occurred in that video, nor will it actually be shown in this video. So with that out of the way, let's get into the video. Hey everybody, welcome back to the channel. I wanted to make this video to demonstrate how I prefer to tune an Atrius Super Selector or FRS setup. And I also wanted to go over some very critical details on how you can actually make sure that the issue you're experiencing is related to this specific issue. There's actually quite a few flaws in my opinion with this design, even though I think it's a really cool design. I think it's really simplistically genius is the best way I can put it, but I think it was just poorly executed. There's some things that need to change, but chief among those things has to be the oversized safety cam for the lever itself. So I have here a handful of things in front of me that I'll go over. I have here off camera a receiver with a tuned Atrius setup, and I'll explain what's going on here in a little bit. I have a Meditoya micrometer because people were telling me, hey, you should use a micrometer. So yeah, all right, I'll use a micrometer. And I have here a mil-spec style fire control group. This is just a Schmidt tool single stage with a flat bow, nickel plated. Geometrically, this is functionally identical to a Schmidt tool single stage trigger. This is typically what you find with a lot of super safeties and stuff like that. One of my favorites in my opinion. Really well designed. Anyway, I have here 4 unmolested Atrius levers. One of these is from the very first run. 3 of these are from the most recent run. This came in the mail like a couple days ago. The bodies, the levers, the springs, all that stuff. And this is actually a nearly ruined but still functional tuned cam. And I'll go over this in a little bit. You'll notice that I have these Schmidt tool 2-stage triggers up here, which I'm not going to go much over these right now, but I only have these here to tell you, the viewer, like, hey, this video specifically has to do with this trigger group. I don't want you to assume that just because I'm showing you how to tune this one, it means that it's going to work exactly the same on how to tune this one. And I actually took some time to do a little bit of test fitting with this style of trigger here. So this would be similar to like a LaRue, similar, I suppose. But this is probably one of the better designed 2-stage triggers in my opinion. But this actually doesn't work with this. If yours does, I'm so happy for you. But here in my experience, these don't work, but for a completely different reason. It's related to the trigger tail. But it's not actually related to the cam itself. So actually, the really cool thing about these designs is I can finally confirm this. These are not affected by the oversized safety cam of this design. You can actually put literally a gigantic 375 cam in there, and you're not going to get binding like you would with a single stage. However, it still doesn't work. It has to do with the geometry that this was designed for. These were designed for ultimately really these. This is what these were designed for. These work great with these because they're designed for that extra travel there. Well, anyway, before I stray too far off topic, I just want you to be absolutely sure what this video is about. It's not about tuning for absolutely every trigger out there, but it's specifically for tuning single stage style triggers that are designed for mil-spec safety cams. This might work with some cassette triggers out there. You have to verify yourself, but I can say with confidence that this is going to work great for these because I have the most experience with these style of hammers and triggers. And the issue that these suffer from is mainly related to an oversized safety cam. So before I go on to show you how to actually tune this trigger to an oversized cam, I want to present to you the idea of first checking to see if you even need tuning to begin with, because it's possible that you don't. And I would say the easiest way to check for that is by doing a very specific manual function check. So an oversized cam will manifest itself like this. So I have here a mocked up here example. This is an unmodified cam, an unmodified selector lever. Everything here is completely stock, unmodified. And I have here a mil-spec fire control group that I know everything is within tolerance. So the way this is going to manifest is if you push this into the third position, you fully depress the hammer, and then you have a bind right here. So that is straight up an exact symptom of an oversized cam. The inability to turn the safety on, because again, this is safety on, safety off, safety on, safety off. The inability to turn the safety on whenever the hammer's being depressed. So I have here an example. This receiver, this tuned receiver, this is how it's supposed to be. So the cam diameter was reduced on this one rather than the trigger, but this is how it's supposed to behave. You depress the hammer and it comes back with literally no binding at all, like glass. That's how it's supposed to be. So before I move on, I want to clear up one thing. So in the previous videos, I talked in my very first video showcasing a bunch of receivers. I said that I recommend you take this down. You reduce the cam OD, and then in the following video, I kind of took a few steps back and I said, hey, I think the best thing you should do is to take material off of the trigger. And the reason why I said that is because at the root of the issue is 100% Atrius's design. This cam is oversized 100%. We looked at the prints. This is straight up not a good design in that regard. However, I think it's much easier for you, the end user, to modify the trigger itself. This is a way less expensive part. They're a lot more plentiful, they're easier to get, and it's way easier to take off material from a flat here than it is to consistently maintain the outer diameter on this round cam OD. So, with that out of the way, I'm going to show you how to adjust this design. But real quick, I want to show you this. Feel free to skip to the next section if you want to get on with the tuning portion of this, but I want to show you this. So I'm going to use this micrometer to show you first that it's calibrated. Here, closes on 0. I want to show you that these cams are oversized for sure. So in the last video we talked about what that cam OD is supposed to be, 330 plus or minus 5 thousandths. Now look at this one. Let's get started with just this one here. I'll show you what it looks like. So this is at 371. We're at the 350 tick mark, and then 321 and probably like 8 or so 10 thousandths. Can't get it all the way around, but yeah, like 7 10 thousandths. About 7 10 thousandths. So 371 and 7 10 thousandths. And then this one is also at 371, just under 378, or 372, sorry. 371, and let's look at this one here, this final third example. 372. So obviously that's oversized from the mil spec. Mil spec is supposed to be 330 plus or minus 5 thousandths, and then this one's at 371 and 372. The one in this one's actually at 375. So with that out of the way, let's go ahead and start showing you how I would tune this setup here. So before I go into this, I want to take some time to go over the exact operation we're going to do, like what we're going to change on this, why we're doing it, and why it's really only safe to do it with this design, with the Atrius. So something that we talk about a lot here, or that I specifically mention a lot, has to do with the oversized safety cam of the Atrius. And something you may not know is that the Atrius actually has two safety cams in two different locations. So we have one here on the lever itself that we already know about, oversized, and then we have one here on the body of the Selektor itself that's also oversized. Although I don't know by how much because I can't really measure it. Maybe I can, but I guess I can't. I don't have time to do it right now. But it's right here. So let me grab my pointer, and that safety cam is this one right here. Right here. This, whenever this is in the safe position, this is your trigger stop that prevents it from coming up farther to release the hammer. And then whenever you go into semi, here is your relief cut. So now this can come up and the trigger can be pulled to release the hammer. And then whenever you go to super safe, it's the same thing. It's just that this lever changes the position of the lever. This selector lever drum here changes the position of the lever. So actually this is oversized. I just don't know what it measures right now, but I know for a fact it's oversized, and I know that because I'm going to show you this. So I'm going to grab the pulse sample machine gun receiver. So this is a genuine machine gun receiver, and I'm using this as a baseline because this is how things are supposed to interact. If I'm in the safe position and I fully depress the hammer, you have a little bit of trigger slop, and it's still in the safe, so it doesn't allow you to travel far enough to release the hammer. This is all mil spec. This is how the dimension is supposed to be. Fully depress the hammer. I'm actually pushing it more than it can go, so it's actually pushing it farther. And you still have a little bit of trigger slop, and that's good. That allows this to cycle without having any kind of parts binding or mechanically binding against themselves whenever the gun is cycling. So that's good. Now I have here my other Atrius receiver. This has the modified cam. The actual lever itself is modified, but the cam itself here, the trigger stop safety cam, is not. So if you fully depress this, you have nothing. It's binding a little bit. If I release a little bit, you have that play again, which is good, but it's very, very, very little. If I fully depress it, it has nothing. So we have mechanical binding there. But again, this is not that big of an issue because that's a fixed surface. It's not moving. The one that moves is whenever you go into the third position and you have this. But that's fine. As you can see here, they have no binding there. But now, since that is oversized, I want you to understand that plays into why this is safe to do. Because understand that the modification I'm about to present in this video is practically unsafe for any other design. But since we have here an oversized lever cam and we have an oversized body cam, they're both oversized. We can remove material off of this and still stay within the safe range of operation so that you're not going to have two fire positions. Because think about this. This is your standard selector. You have this relief cut at 330 diameter, at 330 thousandths plus or minus 5 thousandths to allow for that play, to allow for that motion whenever the hammer is depressing. But it's not so much that it allows you to pull the trigger. Whenever you flip this, the trigger is allowed. Keep this in mind. There's very particular verbiage I'm using here. Whenever you turn this to safe, you have this cut here that allows the trigger to move up farther to release the hammer. Okay, if you're removing material off of this back here, guess what you're doing? You're allowing it to go up farther. So if you take off too much for this design, if you take off too much for this design, it's possible that you're going to have two fire positions, just one with less over travel than the other. So the good thing here is that at the very least, Atrius designed this oversized, probably not on purpose, probably by accident, but they did it such that you can actually safely remove material off of the tail of the trigger so that you're still going to be within the safe limit of operation for this. So you're not going to have two fire positions and a super safe position. So I have this here marked with paint so you can see where we're going to remove material. Now, one thing I need to just make sure that you understand is that the contact points really are like way back here. But just to make it easy for you, the viewer, for you, the end user, you can actually remove material up to this line and you can still be perfectly safe. It's just a cosmetic thing. It'll be easier for you to remove material evenly across, and it's just an easy visual indicator for you. Now, I'm going to remove this paint here to get an accurate top to bottom measurement with a micrometer so we can keep track of how much material we're moving. But at the end of the day, the idea is that we want to remove enough material from this so that this can come up and the lever won't bind as it's coming back. So what we really want to achieve is we want to achieve this. We want to remove enough material from this right here until we can achieve this. That's the goal here. That's what we want. We want third position, hammer fully depressed, lever to come back smoothly and beautifully, just like that. So let's do a little bit of math here. So what do we know about standard AR-15 or M16, M4 safety cams? We know that the outer diameter of these is supposed to be 330 thousandths plus or minus 5 thousandths. We watched my last video. So considering that, knowing that these Atrius cams are oversized, these measure 375 plus or minus 5 thousandths. That seems to be consistent with the measurements I'm getting here. This one's like 377, and then we have these other ones that are like 371-ish, 372-ish. So they're kind of within that same tolerance per the print. So knowing this, we have a difference of 45 thousandths, nominally speaking, 45 thousandths oversized. But remember, that's a diameter, not just on one side. So considering that that the difference is 45 thousandths, we're not going to take 45 thousandths off the tail of this trigger. We're going to take off 22 and a half to get to the same practical function. And the reason why is because the diameter isn't just on one side, it's on both sides of the circle, right? You have 22 and a half and 22 and a half on this side to make that difference. So that means that to get the same thing, we're going to have to remove about 22 and a half thousandths off of this. But the reality is that you probably don't even need to remove that much, because the this upper receiver I have here, this one that I keep showing, this cam, I only removed about 12 thousandths off one side to make it work, and it still has a lot of room for error. So like, look at this. If I depress this and I put this in the safe position like this, you still have only a tiny little bit of over travel. So that means that you still have a lot of room for error. So you can actually remove more than that, but you only really need to remove as much as you need to, right? You don't need to remove all 22 thousandths. You can probably even go more than that, but you definitely don't want to go more than you need to. So what I'm going to do is I'm going to take off 10 thousandths off of this and then come back and check. But one thing I should mention for you is that I would say don't even bother trying a file, because this is some very hard steel. This is, as you know, Schmidt Tool, they investment cast these and then they case harden them, and they're very hard. So what I'm going to have to use is a Dremel with a diamond bit. So I'm just going to do this by hand. I'm going to take off a little bit at a time, and I'm going to measure with the micrometer on the tail on each side. I'm going to measure with the micrometer on each side, here and here, until it's even, and I've removed about 10 thousandths. So I'll come back whenever I get that done. Hey, just a real quick intermission. In the last segment, I was showing that I was going to use this diamond bit. I'm just really quickly interjecting here to show you that I'm actually switching to this one, because that last one was just not cutting the steel at all. So I have to use this stone bit, and this seems to be doing a much better job. That's all. Here's the more or less finished product. This is definitely not my cleanest work. This is not even a super duper flat cut, but this is going to work just fine. You can see it's very clearly not perfectly flat, but it's going to work fine. So before I started to cut on this one, it measured around 326 thousandths. So it was like here, yeah, like here, on the micrometer. Passed the first tick mark for the 25 thousandths, and it was just over the first tick mark there for 1,000th. That's about what it measured on each side. One side was at 326, the other side was like at 325 or so. Now let's measure each corner and see where we're landing at now. So we're gonna measure just the corners, because those are the contact points. Top to bottom, this is about 314 thousandths on this side, so effectively removing about 12 thousandths of material. Now let's measure the other corner and see where this one falls at. I'm expecting this one to actually be a little bit smaller. This one's at 310 thousandths. So effectively a 15 thousandths reduction on this side, and this side is like 12 thousandths. So it's obviously not perfectly flat, but it doesn't need to be. This is going to work just fine. The steel is still very hard on the outside, so I don't presume that this is going to excessively wear while this is under operation. But let's go ahead and install this into the receiver and see how it manually functions. All right, so here's the final moment of truth. This is everything mocked up into this receiver. This is that trigger that I just adjusted, took some material off the top. Let's go through a really quick manual function check. So in the safe position here, we have no dropping of the hammer, so that's very good. The tail does nothing, so that's good. This lever does nothing while I'm holding the trigger, very good. We put it in the safe position, we release the hammer, that's great. Hold it down and we get an engagement on the disconnector hook, that's good. The lever does nothing, very good. And it resets just fine. So let's go into the third position and let's see how this does. Let's try for a manual function check, just a manual reset without depressing the hammer. Release the hammer by pulling the trigger, great. Goes on the disconnector hook, very good. Push this back, no timing issues, and it resets just fine. If I push this forward, I can release the hammer whenever it's all the way forward, so it's very good. Now let's do the same thing here. with the hammer depressed. So whenever we're in the safe position, remember we have two safety cams, one that's oversized on the lever itself and one that's oversized on the body itself. We took off about effectively between 15 and 12 thousandths or so on each side of the trigger tail. Let's depress the hammer. Do we have a little bit of take up, a little bit of over travel? And we sure do. It's great. It's not a lot. It's not too little. This is very, very good. And I'm pushing the hammer quite hard. So this is great. This is exactly what I'm looking for. It's very similar to the machine gun lower receiver. In the safe position, this is all the same, so there's nothing here to check whenever we're doing this test. The third position, here we go. So we're going to depress the hammer. Do we have any binding? Nothing. Beautiful. That's how it should be. Absolutely no contact unless you pull the trigger. Which, again, your trigger finger will always pull the trigger farther than the hammer pushes it back. We just don't want the hammer to do it so much that it's contacting the lever. And whenever you have an oversized cam, as I've stated before, you have an oversized cam, this will be enough to contact it. That's no good. That's no good. Mechanical binding. So this is good to go. So now I want to go over real quick. Even though it's really easy compared to this, even though it's really easy, this is a new one. I haven't touched this one, but even though it's a lot easier to take off material off of this flat here, I still have to caution you, because if you look carefully, let's see if I can zoom in on this and make it look a little, look at that. You see how the tail of the trigger, the very, very tail, has like a curves downward. So that curve is your enemy, because one of the inherent design flaws of the Atrius is that, because now it just has to be this way. I have like pictures of how this mates up with the trigger tail. It just has to be like this for it to work properly, for it to reset positively and smoothly. So the issue is that because of the inherent geometry of this cam, it's very easy to override the trigger whenever the cam is inching forward. So what do I mean by that? This is what I mean. So this is the safety off, safety on position. There's obviously space in between those. It's not like well, it kind of is like a selector in the sense you have like in the middle portions, right? But here you have safety off, safety on. If you have the safety on with the lever all the way back, it's pretty dang difficult to forcefully override that. But if you start to push it forward, it becomes increasingly more easy. You can see it's kind of pushing it forward a little bit. Eventually, it just forcefully overrides it. If you're like here, you can override it with just one straight pull. Really, really easy. That's obviously not ideal. And so you prevent that from happening by, you can actually time it per se a little bit better so that you can't override it farther forward. If I explain myself well enough, you can mitigate this by making this cut in the back here as flat as possible. So the ideal way to do this would be to put this in a manual mill or a CNC mill if you have one, and just take 10 thousandths or 15 thousandths off the top and make sure it's perfectly flat, because that's going to make the timing a little bit better. And part of what makes that timing a little bit poor is the fact that you have a curve here and the fact that you have a curve there. And for here, it just has to be that way. So I would just caution you to make sure that you're keeping this as flat as possible, that cut as flat as possible. Ideally, you're not taking anything off of here. You're kind of just taking it off from my fingernail here to about here, and this just kind of stays the same. So that's how you tune one of these. And that's actually one of the reasons why I recommend that people stop cutting on these, because it's really, really easy to take off too much material off the top here and make the cam oblong. And that's actually what happens. That's what happened to this one here. So this one's not fully ruined. It still works. It's just a little picky. You have to be careful not to pull the trigger way too hard or you override it. So you can see there, compared to this one, let me grab this fresh one here. You can see there that I clearly removed quite a bit of the front. And what it really needed was actually kind of back here. This one was done hastily. I wasn't being careful. But yeah, for that reason, it's just way too easy to ruin these. I would just say it's a lot easier to take off material from a flat. So yeah, so that's pretty much it. That's how I accomplished the adjustment of my triggers to work properly with these oversized Atrius cams. And I have to just reiterate this. This modification is really only recommended by me for this style of trigger. For the semi-auto, single stage style of trigger that works like these do. And the reason why is because, again, as I mentioned in the previous segments, there's a safety issue. If you were to modify one of these, take 20 thousandths off the tail and put it in a system that has a selector like this, you run the potential of having 2 fire positions and you lose your safety position. So I don't recommend that you use this and just expect that you can go back to a standard configuration. This is pretty much exclusive to an Atrius because, again, that oversized cam on the lever and the oversized cam on the body. So don't try this for anything else. This is only for an Atrius. Another thing is that this modification is specific to this style of trigger, the single stage mil-spec style triggers, and that's because it's the experience that I have with them. I don't really have a lot of experience with single stage cassette style triggers, but if they work similarly, maybe you can adapt this method to those. But for now, I can only say for sure with confidence that this method that I use is really only effective and safe for this style of design. If you want to try it on something else, you have to, I can't stress this enough, you have to verify that it's safe to do. Another thing is that this Schmidt tool 2-stage, just like the 2-stage version of this trigger, this doesn't quite work with this. If it has its own separate issue, like I said, these are not affected by the oversized cam, but they don't work properly with the Atrius design. I have 2 triggers total, 2 fire control loops. One of them barely works, the other one doesn't work at all. So it's just clear to me that this design was not intended for this. To me, it seems like they're designed for this. Like this is exactly what they're made for. It's just that unfortunately Atrius didn't take into account the proper cam diameter. Otherwise, they seem to work the most consistently whenever they are clearanced to work correctly. So thanks for making it to the end of the video. I really sincerely hope that this was helpful for you. If you have questions on how I did this or any specific things, please leave them down in the comment section and I'll try to get to them whenever possible. If you want to send me a message, you're always welcome to send me a message on Instagram. I'm going to go ahead and link that in the description. I'm going to have my handle there so you can send me a message. Once again, thank you for watching. I hope this was helpful for you and have a very blessed one.